basically what I'm up to. Thanks.
I work at a startup called lalu.com, mostly doing Ruby development, but actually doing almost everything because it's a startup. And one of the things that we've recently done is we moved from a traditional data center into the cloud as a traditional data center, and I think we need to change that.
I'm Justin. I work here at Factual. We primarily use the AWS zone.
I'm Jamie. I just started an internship here, so I'm just looking to learn.
I'm Ali Kazi. I'm a program manager in Amplio Technology, working on websites for farmers for most companies. I want to learn about CDN and the cloud, how we can use it to speed up our sites.
I'm Mojtaba. I'm PHP developer, and I'm really interested in high performance sites with high scalability.
Hi, I'm Mohammed. I'm iOS game developer. I'm looking here for something more to learn.
My name's Lloyd. I'm a web developer.
I'm Wesley, inventor.
My name's Costa. I work at Amazon, and I'm here to learn.
You live here?
Sorry?
So you live here and work for Amazon?
Yeah, I work at the IDD division of Amazon. That's here now.
I'm Ryan. I'm with Bryn Neal International, which is a IT staffing firm, and I'm just here to learn as much as I can.
Hi guys, my name is Armin. I'm a patent lawyer, and I'm here to learn as much as I can on cloud structures.
Hi, my name is Moti. I'm with Co Systems. I'm the CTO. It's a Swiss company. We develop extensions and cloud solutions for SAP.
My name is Britt Ehrig, and I'm actually a consultant in sort of the web performance and scalability field right now, and actually I've done some work with Cedexis in the past, and I'm just here to see what Cedexis is up to right now.
Oh, hi, my name is Philip. I'm a web developer too. I just want to learn more new technology.
Hi, I'm Nick. I make mobile solutions integrated with cloud servers, APIs, and I came here just to see what's new in the field of scalability.
I guess I'm George. I work at Cedexis.com, so a lot of e-commerce stuff. I work with Amazon AWS, EC2, S3, and Akamai, and I've done other things like that in the past, so just here to see if there's anything new that can be better for us.
Hi, I'm Paresh. I'm a software developer with Samantha. I develop web application in .NET.
I'm Samir. I am an architect at Amgen, and I work with Amgen websites.
Raymond Ohania, Java consultant.
I'm Don Rose. I'm a technical writer with an AI background who's getting back into programming again. That's why I'm interested in learning more about it.
I'm Harijat. I'm a software engineer. Just graduated. My emphasis is on the lab development stack.
Hi, this is Vishal. I'm just here with Kanisha.
Is that it? We got everybody? Anybody missing? Oh, did you want to say? Okay, so before we get started, I just wanted to thank Marty at Cedexis for sponsoring the food and coming out here. Also want to thank Factual for hosting. They're always been a great host. And before you leave, if you can do them a favor and just stick around for a minute and help put the chairs away, that would be really helpful. And let's see what else I want to say. We have on the 19th, we have a MongoDB meetup. So keep that on your calendar. Do you have
Any good Mac
jokes?
No, good Mac.
Not a good joke.
PHP developer.
Any PHP developers using Mac as their primary platform? Sounds good. We actually wanted to make a talk for PHP group on kind of building a development environment or different platforms with Mac specific things. Can I use
Sam.
Stack? Yeah. Alright, I guess that's it.
So So without further ado, we're going to have Marty Kagan take over here, and welcome.
Can you guys hear me in the back okay? So I'm going to warn anyone planning to go to Structure next week in San Francisco? Okay, so basically going to rehearse my talk for next week with you. You guys can help me refine it, so please, that next week I'm going to be speaking in front of 3,000 people, and I want to be able to see their faces, so this is my opportunity to actually get feedback and help make the talk better, so please speak up. If I lose you along the way, feel free to interrupt me. Kind of quick background. I spent 8 years at Akamai Technologies. Started Cedexis 3 years ago, 2009, with the idea of trying to collect. What we saw in the market was people trying to move to the cloud, and moving to multi-cloud, multi-hybrid cloud strategies. And what was missing was a view of what the end user is experiencing. So our goal was to go out there and capture what are the actual end users seeing when they go to an application, they interact with the web or mobile app. We went out and today we're testing or monitoring the performance of 200 public and private clouds and CDNs and data centers around the world. We convinced 250 companies to deploy a JavaScript tag on their web pages, so that every visitor to that site would then become a virtual agent for us and feed us data. On a daily basis today, we're capturing 1 billion measurements from 30,000 networks around the world, and that all feeds into both our historical reporting system as well as a real-time load balancing system. So just sort of background on where this data is coming from. What I wanted to talk you through today was looking at what are some of the stories we can tell, what's some of the knowledge we can extract from all this data that we're collecting, specifically looking at cloud. So we're talking about how reliable is a single platform, what's the benefit of deploying an application across multiple clouds instead of just a single cloud, and what combination of providers gives you kind of the best performance, or what's the best way to blend those different platforms together. Does that make sense? If I followed you so far, we're good for the rest. So we're looking at, for reliability, we want to look at Google App Engine. It's fairly typical. So we have a test application running in Google App Engine. What we see, which is 90th percentile, so kind of worst case performance. We see good performance in North America and in Western Europe. Sort of okay performance, starting to get a little poor performance. You start looking at Brazil, Russia, India, and China. And pretty poor performance when we start looking at things like Africa, Australia. Not too unexpected when you're talking about so many servers that are hosted primarily in North America.
Question.
Yes.
Why is Greenland so good?
And Syria. One of the issues because the data is coming from end users, we do get some skew in terms of there are places like France, Germany, where we get a lot of data, and there's places like Greenland where we don't get a whole lot, so a few measurements can kind of skew the numbers. So I'm sort of at the mercy of the volume that I get. If you go to our Cedexis.com, we post on there every day a summary of all the data we collected the day before per country. You can see 10 million measurements from Saudi Arabia and 200 million measurements from France. And within that country, what are the top 50 networks where we see the traffic, what percentage breakdown each network kind of represents in terms of the traffic from that country. And then all the performance data that we have from those end users in that country, looking at different clouds and CDNs. So we see May 20th, the sort of picture, if you look the next day, fairly consistent performance from day to day, except on the 22nd when everything went to hell. And what we saw was, if you looked at the 50th percentile, you really didn't see anything. It was really just, there was a brief period of time where the latencies really spiked really badly. It only really affected, create a bunch of outliers. But this is typically when we monitor the data, is what we're seeing is things generally work pretty well, and things are generally pretty consistent. But when they're not, it can be very dramatic, it can be very global, and everyone can have essentially outage. So the lesson here we try to tell our customers is you really don't want to be dependent on a single cloud. No one is 100% reliable. They may be generally out, that you don't see catastrophic multi-day problems. But you are going to see in any given week either localized problems where users in Telecom Italia can't reach your application, or something like a global kind of problem like Google had.
So let's see, in Syria.
In Syria, everything's always good in Syria. So the second one thing is this is more benchmarking. So how do the different clouds compare? Let's look at, you guys, most of you are on Amazon, so we'll kind of start with Amazon. If you look at EC2 Virginia, the EC2 East region, great performance in North America, not really particularly good down in South America, really pretty poor in Southeast Asia and Asia Pacific, but not bad in Europe. If you move your application over to the EC2 Ireland region, now you get great performance in Northern Europe, but now you've sacrificed North America, and things are even worse now in Southeast Asia. If you deploy in Brazil, now that really gives you the coverage down in South America, but again, only really in South America, and really only in Brazil because peering between the various countries in South America isn't particularly great. Or you can deploy in their Singapore region, which is going to give you some good performance down here, although noticeably not particularly good performance in China for some reason. But at least it kind of covers that piece of the world. And if you mix them all together, now you've got this nice big blue planet where everyone in the world, with the exception of Central Africa, is getting an acceptably good performance from your application. Whereas if you select just a single one of those locations, right, you're sacrificing a piece of your audience. And we see the same exact behavior when you look at Windows Azure. They've got Azure US South, that's great for North America. You can move over to Azure Europe, Azure Asia, which actually has very good performance in China. And if you blend them together, you get almost the identical picture of EC2, the exception being they don't have anything in South America. So if you lose Brazil, but you gain actually better performance in China if you select Azure. And in case you don't like working with Pacific Northwest companies, we also see we work with Cloud Sigma, we work with Vox Cloud, a bunch of other newer cloud companies that again have gone out and deployed the same in North America, Europe, and Asia, and you can blend those together to get that global coverage that you really need to ensure that every visitor to your site is not sitting there waiting for the application to load. Questions? Does that make sense?
Any analysis of Rackspace Cloud?
We only monitoring Rackspace North America. I know they've now opened a European option. We aren't currently monitoring that one. To be honest, it's almost identical to the Google App Engine data I showed, where great here and just sort of not good anywhere else. So again, the lesson here is you really want to, if your audience is global, if the people, then you really need to be global as well. You can't rely on a single location. Lastly, looking at sort of how do you blend, we take 1 billion measurements a day and we start crunching it, do the basically big NP analysis of saying what combination of which one provider is going to give us the best, which combination of 2 is going to give you the best, which combination of 3, and often you find that it's not the first and second, it's really the first and third, or the first, that gives you the best overall coverage. But we looked at, even once you identify who the sort of the best ones are, the question is how do you mix them together? If you do the kind of the dumb way and say, all right, the best in North America, this is just looking at the US, the best performing in North America is the Amazon US East. Second best is Vox Cloud New York. But if you start doing round robin across those two, well, now performance gets worse. Because now you've taken half your traffic at the best and half your traffic at the second best. Performance is getting progressively worse. And if you add 3, 4, 5 platforms, if you're just doing kind of stupid round robin across them, you're actually degrading the user experience. What you want to do is take all the data from yesterday, and look at performance from, look at your logs, and look at the performance from every AS in the world, in the US. You've got 4,900 networks in the US where your users are coming from. Figure out for each of those networks, where do they get the best performance? And say, okay, for tomorrow I'm going to apply that as like a set of static rules to all my users. And what you'll see as you add additional platforms is that performance gets better. Because now you're intelligently selecting and saying, I know that Rackspace is the best choice for people coming from Verizon, whereas Azure North is the best choice for people coming from Comcast or Bell South. Definitely better than round robin. Definitely a big improvement. You see the improvement over time. The only problem is it starts to flatten out. That basically beyond 3, you're not really getting much marginal benefit from adding a 4th or 5th platform. This is the approach that Amazon uses. Amazon recently announced latency-based routing for Route 53, where they're basically taking all the Amazon logs from the day before, they crunch them, they build a map, and for the next 24 hours, that's...
Yeah, I was just wondering if you actually had slides and data on that, because we were starting to get into that.
We haven't started monitoring it. We basically did a look-back analysis, took our data and did a look-back analysis, and if we had applied that same logic to our data, we said for each so the blue line is basically crunching the data we have and said if we had taken all the results from May 20th and applied that to all the routing from May 21st, how good would the routing have been, and what kind of performance would each of these users have seen across the
Before we talk about round robin DNS, so this is routing only, or is this an intelligent DNS that knows the IP address source and can match it to
So in this case, the red line we're looking at just dumb round robin.
Right.
Just have you arbitrarily sent the traffic any which way? Take all the measurements we have and just crunch. If we had sent them randomly, what performance would they have gotten? The blue line is if we had done the analysis, we basically ran all the numbers from May 20th, figured out for each ISP which was the best location to send them, and then applied that across all the data from May 21st and say what performance results would those users have seen if we had done that kind of intelligent bucketing of matching the client location, client IP address, in this case the client AS, the network, to one of these 5 cloud
So you have to use an IP geolocation service in conjunction with something like that, right?
You can either so you can do it 2 ways. You can use a geolocation service to identify it. You could also just look at take the IP prefix and just bucket them that way. You could use BG. There's a bunch of ways if you're just trying to map an IP address to sort of aggregate a bunch of IPs, you don't necessarily have to use.
Like on the AS.
We were doing this is done by network, not by city. So we're not looking at. What we found in our data is that mapping things by city or state is fairly worthless. But it's fairly inconsistent. Where you start to see real consistent behaviors when you get down to looking at users from what network they're coming from, whether they're coming from Cal South or Comcast, not whether they're coming from Atlanta or Miami.
Oh,
that's really the big determinant.
That's why you look at the prefix of the block, the IP block, and see what.
Exactly.
Okay.
So the third way we look at it is instead of doing it based on static, kind of looking at yesterday's results, if you did it in real time, if throughout the day, every minute of the day, you're looking at who right now has the best performance, and made all your mapping decisions based on that data instead of on yesterday's data, then we start to see substantially better performance because now we're able to react to changes in real time, changes in the network in real time, and we see not only substantially, really 50% performance benefits, but also we're not capping out at 3. We're seeing benefits even all the way down to 4 or 5 platforms. And so the recommendation for customers is not only do you want to be using multiple clouds, but you want to be doing the routing across those clouds as dynamically as you can, and not relying on either static or.
Now, is it done through routing, or is it done through like a DNS?
Through DNS.
Intelligent.
In this case, it'd be intelligent DNS, something that has actually a feedback loop, so that you're capturing this kind of performance data and feeding it in real time into the decisions rather than relying on.
So do you have to write that, or because I don't think Bind 9 does.
Bind doesn't do it. So this is something I guess we're trying to avoid the sales, but we sell this, and
this is software you work.
There are companies out there who offer real-time performance-based load balancing, and this is basically, we're going to do, academically speaking, if you look at the billion rows of data, you can sort of prove experientially that doing it, having a feedback loop between performance and decisions has a big impact on cloud performance.
Can you just give us an estimate for this real-time feedback loop? Like, how real-time? Is it 1 hour or something?
In this case, where we modeled it, we did it based on every minute. So if you took the results from the last minute and applied them to the next minute, we see the results. In practice, in my business, we have a 10-second delay between when we capture data and it affects decisions. So that's harder to model.
But if it's done by DNS, then you get cached.
You get cached. You get 20-second caching rules and things like that.
Can you apply this across if you want to use multiple CDNs, for example?
Yes, in fact, so that's the majority of my business today. Is people using this for CDNs. So I've got. So we'll look at CDNs. Here's looking at Akamai 50th percentile map for Akamai. So if you look at the median performance for Akamai across the world, things are pretty blue. They struggle a bit in China, Middle East, where they don't have any servers. But in general, they've got pretty good, and this is why Akamai charges a big premium for their service, right? Median performance, very, very strong. We start looking at Edgecast. Is anyone from Edgecast in the room? We're local here in town. NetDNA here, Chris here. Okay, so try not to trash on our partners. Edgecast, for North America and Western Europe, they're indistinguishable. The performance is almost identical. If you're paying a premium for Akamai in the US, it's sort of questionable if you're really getting tremendous value for it differently. It's also ex-Akamai. Where you start to see the differences between Akamai and the competitors is when you start looking at things like South America, where Akamai's got good coverage and they're blue everywhere. Edgecast, which has no coverage in South America and really has to serve it from Miami. And then over here, where again they've got some coverage, but it's not quite as blue as Akamai's coverage. And then NetDNA is also a local company, much smaller, kind of nimble startup. And again, they don't have they don't have good coverage in Southeast Asia. They don't have good coverage in South America, Africa. But if you're really focused just on North America, Western Europe, you really don't see much in the way of performance differences between small, very responsive, very inexpensive NetDNA and very large, bureaucratic, very expensive Akamai. It's when you start looking at 75th percentile, the story starts to change a little bit. Now all of a sudden, Akamai's story in China is getting worse. The fact they don't have servers in Russia starts to really hurt them. And we see again similar things with Edgecast and NetDNA. And once you get to 90th percentile, now you're looking at kind of what is everyone seeing, all the Akamai users, not just the ones who are getting good performance, but kind of what's the worst case Akamai result. And this really shows, in some ways, the story falls apart a little bit. Around the world, people really are limited by their bandwidth, by their ISP, by their connectivity. Having those edge servers really deployed primarily in North America and Western Europe, there's limitations on how well these networks can really do when they start really trying to reach users in developing countries and emerging markets.
Can you describe a little bit how do you, what are these percentiles? What is it?
So we take all of them. So we collect several. It's a billion divided by a bunch of platforms. So we'll take 10 million, 20 million, 30 million Akamai measurements a day, and we'll say for the course of the day we spread them out and figure out the distribution and slice it out.
Just basically response time distribution.
Exactly. Yeah. So this is we also have data on throughput and availability and connect time, but in this case I was just looking at response time. One of the problems with having a lot of data is you guys know is finding in order to visualize it, to sort of pick something narrowly.
Yeah.
We ourselves, so our real-time system is all homegrown for doing the load balancing, but for the historical reporting like this, we stick it all into AWS and we run big MapReduce jobs and crunch out numbers several hours later.
So does CloudFront mimic the rest of AWS as far as these numbers?
Yeah, they're closer to Edgecast than Akamai in terms of their footprint. They do have coverage in South America. We've seen actually big improvement in CloudFront in the last, say, 12 months. Like they weren't really a contender a year ago, and they're catching up both in terms of performance and more importantly in terms of feature parity. One of the big challenges in CDN space is Akamai has 12 years to develop a very rich metadata language, allows a tremendous amount of flexibility, and other folks are still kind of trying to catch up with that. So we have customers come to us and say, hey, look, I really want to move to a multi-CDN strategy. Who should I work with? What are the options out there? And we'll look at their performance, we'll tag their website, and we'll get the data from their end users and say, well, this is where your users are coming from. This is what performance they're seeing today when they're using these services. It looks to us like we could get better performance in these key markets if, in addition to using Akamai, you also signed up with this regional provider in Brazil and this regional provider in China and this regional provider in Russia, and start to build more of a patchwork quilt of providers that'll give you the best global coverage. And the challenge is, what are you trying to do with the CDN, and how deeply enmeshed are you in Akamai's metadata language? Do you even have the option of using somebody else, or are you kind of are you sort of dependent on the functionality that you get from many companies? Like today, we're working with like MSNBC and a lot of the media companies in Europe who are actively trying to move their business to not trying to eliminate Akamai from their business, but just trying to get away from the single vendor lock-in. Sure. So 90 percentile, things start to get pretty bad. What's interesting is you look at the blended view. You take all the
So the real-time performance stuff that you're doing to like be able to determine which cloud provider to use, or in this case like CDN, you guys also take into account like cost. So for example, like if two cloud providers are the same price, then you can use either one of them. But if one of them is actually a little bit faster but twice as expensive, then it's like, wow.
So again, I was trying to avoid like the sales, the sales pitch, but our platform is it's a DNS application server. Customers write a PHP app describing how they want to make decisions. We expose through the API all this performance data, but the actual decisions are made by their application. So they can write essentially any algorithm they want around the data, whether it's we can pull in load data from their CloudFront account, we can pull in load data from their CDN account, so we can look at how many megabits per second they're pushing right now, how many gigabits I delivered this month. They can put embed whatever costs numbers they want, but we're saying here's the data for this user from this network right now. Here's what we're seeing in terms of availability and throughput response time. the customers get to decide how they want to make decisions based on that data. So some of them will say, look, in the Middle East, it's a strategic market for me. I'm trying to build my brand in China and Saudi Arabia. Cost is not an object. It's whatever's fast to send it there. In North America, if it's only 20% slower, but it's half the price, it's good enough. And so they'll write these kind of good enough algorithms. Where I have this commit. If I haven't filled my commit, I might as well fill it. But if I'm over my commit, now I want to get really aggressive on offloading. Or I want to serve it all from my origin server, my own data center, unless I see a spike, or unless it's going to be twice as fast somewhere else, in which case it's worth it to me. So we try to stay out of the business of deciding who's the best. Just say, here's the data, do with it what you like. My last point: if you look at sort of this, this is looking at blending together like 25 different CDNs, which no one in the right mind would ever do. But just sort of theoretically, if you were to sort of take the best of all the providers who are out there and dynamically just select the best one at any given time, what you see is really kind of this: everything's blue, and it stays blue, longer, better. Even if you get out to the 75th and 90th percentile, you're still not seeing a whole lot of the same amount of red that you see with the single provider, because I'm taking advantage of regional providers in these various markets. So I have some examples here of customers who have moved to a multi-CDN, multi-cloud strategy, what they're seeing in terms of the actual end user benefit. So not looking at sort of milliseconds, but looking at, in this case, these are page load times. Ideally, sort of the aptX threshold says you want all your pages to load in under 4.8 seconds. What we see in reality is with a single vendor in many places in China and a lot of the world, a lot of key markets, page load times are much worse. And as soon as they switch to a multi-cloud strategy, well, in this case, a multi-CDN strategy, they're able to get everywhere except for China, where you saw a 3x performance gain, and just now barely over the line. Substantial impact on user performance. So this is really just moving from in this case, Akamai to Akamai plus my data center plus the cloud to deliver my app. Piaget was a luxury watch brand, I think, in Europe. They said, look, all we care about is China. We go to the rest of the world, trying to build our brand in China. And they saw, because their site became faster, the result was a 22% reduction in bounce rates, 15% increase in page views per visit, and people spent 16% longer on the site. For them, for a marketing group, that's very substantial numbers. France Television saw a 25% performance gain, which for them meant a 12% increase in ad revenue. When we talk about this stuff, it's not just an IT thing. It really has a big business impact when you start to look at adjusting performance and availability. And my favorite one is Euronews. They went from Akamai to they started talking to level 3. Akamai came in and said, hey, we'll drop your price from 41 cents a gig down to 3 cents a gig if you give us exclusivity. Euronews got pissed off and said, you've been ripping me off for years. I don't want to do business with you anymore. They went with a blend of their own data center plus level 3 plus a couple other providers. And what they saw was the page loads dropped. Page load performance got twice as good, just by switching to a sort of multivariant. So I think that's all I got. More of the same. Questions? Yeah.
So part of this thesis is that using clouds as a CDN is actually faster than using CDNs.
No, not. I mean, I'm mixing my metaphors here. We see both. What we see today is people moving from kind of a single source approach, whether it's a single data center or a single CDN, to a world where they're mixing and matching resources, and they're starting to push the applications out to the cloud and move the content onto multiple CDNs, and looking at leveraging these things. These are all interchangeable resources, and you want to figure out what's the best blend of them. So for example, big ad networks they're moving the ad decision engines out to EC2, and they're moving all the delivery of creatives out to multiple CDNs, and it's critical that they always serve an app. You can't. So you don't want to stick. Amazon's had outages just in the last 6 months. You're not going to stick all your eggs in one basket. So they move the application out to multiple EC2 regions. Maybe they throw a rack-based region in there as well, just in case. And then they're just looking at how do we dynamically ensure that any user anywhere in the world who's trying to reach my ad engine is going to get the best performance, the best, and never always be available. Meanwhile, on the creative side, with the actual banners and GIFs, there it's like, I don't need to be locked into a single CDN provider. What I care about is getting the low cost and very high performance, because if the user clicks on the next page before I've actually served the creative, I've lost my 1 millionth of a cent fee. Does that make sense?
Yeah, so multi-provider, your service, you get the blend.
If you were at Structure next week and I gave this talk, would you understand what I was trying to get across?
Yeah, isn't that it? Isn't that the message? Use a blend.
Yeah.
And use your service.
Normally try to.
Yeah.
You should find a service somewhere that does real-time DNS-based load balancing, and you should use that service.
And the data is only a minute old, right?
Exactly.
Do you guys also provide like tools to manage these like multi-cloud systems? I mean, it's great, but
we've sort of avoided
multiple
it.
clouds and multiple CDNs seems like a nightmare.
It is, but there's a lot of companies that like RightScale. There's a bunch of companies who are really focused on the multi-cloud management, and really, I think, doing a very good. I think RightScale does a great job of providing the tools to make it easy for you to manage your applications everywhere. But they're missing is the load balancing piece. The presumption is you're magically going to spread your traffic across these clouds. We're going to take care of how do you spin them up, how do you spin them down, how do you add resources, remove resources. Our sense was that's a kind of not a solved problem, but there's other people who do that exceptionally well. And so rather than trying to do that ourselves, we said we're going to partner with them and focus on this niche, which isn't really being served by the traditional load balancing, the F5s and Cedexis of the world that have been around for 15 years, but really we're more focused on the kind of classic data center failover model, and weren't really designed for this sort of the thing I want to load balance is itself a globally load balanced cloud. And the complaint we heard in the market was IT admins and developers saying, I don't like having to wake up at 3 in the morning to reconfigure my load balancer. I don't want to deal with a static set of rules or a control panel. I want something that's intelligent enough to just do the right thing. And I want to link together the data, the monitoring data that I have with the decision data. So you guys, Catchpoint is a company in town that we're very close partners with. I think they're hands down the best agent-based monitoring system in the world. If you're using Keynote and Gomez today, you should switch right away to Catchpoint. And we're working right now on integrating their data as well. Just trying to take all this data and this monitoring data and make it actionable by creating this sort of automation.
Yeah, the guy, Catchpoint, Mehdi Dowdy, actually spoke to LA Web Speed like three times.
I was hoping he was going to come. I saw he RSVP'd. I was hoping he was going to.
I think he's in San Francisco or something.
Mehdi's awesome.
And who are the competitors to Catchpoint? Some of the other.
Keynote and Gomez are the big monsters in that space. Keynote's a public company. They do 50, 80 million a year in revenue. Gomez was acquired by CompuWare. And they're dinosaurs. They haven't really innovated in 10 years. And Mehdi's this incredibly clever ex-DoubleClick guy who built the agent-based monitoring system that you definitely want to use. We don't view ourselves as competitors with them. We really view our data as very complementary. They give you the agent-based view, which is very predictable, very consistent. It doesn't really capture the end-user experience. These two data sources kind of blend together. You don't want to fire off alerts because we saw some guy on a bus who's going between Wi-Fi bases had a bad experience. Our data is very useful in aggregate. When you look over at thousands and millions of measurements, you start to see patterns. But any individual measurement is not so reliable. Whereas Catchpoint is this box is sitting in Equinix data center on a 10 gig uplink, and if it sees a problem, there really is a problem. You should never see integrate.
So it will be like possible to integrate the Catchpoint data measurements.
That's what we're working on right now. It's another data source. But the two, I think in some ways you need both. That the Catchpoint gives you the Catchpoint's incredibly important for reliability and really understanding what changed from yesterday to today. But it misses the end user experience. Because again, they're sitting in a well-connected data center somewhere. They don't see, they have blind spots. They're only in 50 locations around the world. They don't really see what's happening in 400 networks in China. And they don't see what's going on in Saudi Arabia. And if you're trying to reach these emerging markets, you really want to understand what's happening in every individual ISP in India and not just one box in Singapore. So it's a different and complementary approach.
Catchpoint kind of measures it from a data center perspective, and you measure it from the end user of the browser.
They also have the luxury, because it's their own code running on a dedicated machine, they can do anything. They can do very complex multi-stage transaction testing Whereas because I'm basically a Trojan horse sitting in a browser, I'm very limited in what I can do. The kind of measurements that the data I can collect.
How does it work? Is it just insert like the JavaScript code?
It's a tag, yeah. I'd say it's a free service. It's open. Anyone can join. Anyone can deploy the tag. If you stick the tag in your pages and you're contributing your data, you have access to the collective knowledge of everyone. It's sort of a communist model. Everyone can contribute their little bit. We've got very big sites and some of the biggest global brands in the world who deployed our tag because the data is really interesting. And this idea that the more people deploy the tag, the better and better our data gets because it gives us better breadth and reach. So I would encourage you all to deploy the tag.
It sounds as, and tell me if I'm wrong, as if it was more targeted to websites as opposed to web applications, particularly if those go like session-based things and things that go over SSL.
So the data presented today was all very focused on the simple kind of response times for static content. We do also work with companies like we have customers who are because of VPN as a service. They have VPN gateways around the world, and we do performance-based load balance across VPN gateways. Other ones that are video chat sessions, and so we're basically load balancing across SIP gateways. So we do actually quite a bit of work on stuff that is not kind of. I want to deliver an image, more complex. But again, I think anything's got an IP address. You've got the opportunity to do some latency-based routing instead of kind of static. What's traditionally happened is that people have used geography as a proxy for performance. So why don't you send anyone west of Mississippi this way? And you get guys who are on the road and they're traveling in South America and they're still busy trying to connect into the San Jose gateway because that's what's been hard coded into their machine. Philosophically, you always want to be selecting these things, whatever the technology is, whether it's a mobile app, whether it's a communication protocol. You want to be doing it based on latency and really on experiential data on what's best. This is how Netflix runs their network. Because they've got their own code running on the desktop, they can do a bunch of tests and decide, you really want to catch that stuff over there. What Citrix uses for initiating their Citrix sessions. The problem is on the web, depending on your application, if you don't have the ability to write that logic in, then you need a third-party service that can take care of doing at least provide the compute environment for you to run your algorithm.
But it's also like DNS based, so like DNS data is getting cached, so they do not get like new IP address every time you open like data.
No, it's the guy was talking about BGP sessions, right? It's more like traffic shaping. They're saying everyone from Deutsche Telekom should go this way. We don't have with DNS. You don't have the ability to say each individual this user should go here and this user. There are other ways to do it with HTTP, where there's doing more like redirects and
but like what I meant, like even like when a particular user comes in, they get some kind of DNS data. That DNS data would live on their computer for a certain time.
Exactly.
So like they will be like it provides a certain level of stickiness by design, so to say.
Yes.
And you can probably can you kind of like set up some cookies and just.
DNS I can't because we're below we don't see the traffic. The BGP stuff that you said you were doing BGP. One of the challenges, in theory, the network should do the right thing. BGP sort of detects how far things are away in terms of hops and should ideally route traffic and allow that it routes traffic to the best location.
Even BGP is not perfect. So.
Well, in reality, people skew BGP horribly because cost and business rules. And also BGP has no concept of latency or packet loss or any sort of, it just understands how many hops away. It's like name that tune. What we find is there are tremendous efficiencies gains to be had in not relying on BGP, but instead selecting routes, selecting companies who have multi-home data centers, selecting which IP to send a user to based on this kind of data, rather than just relying on the network to kind of figure out how to get them there. You see substantial performance benefits from kind of overriding BGP and making explicit decisions.
More questions?
I hope that was helpful.
Yeah, that's great. Great. Any more announcements?
We can ask just like curious if we can kind of showcase the Cedexis in that case. You have it.
You mean demo?
Yeah, just to kind of look like. Yeah, what is that?
This back, do we have, is there a,
This is my file.
is it open? Back
Actual
to-
guest, actual guest all lowercase.
I won't tell anybody. It's written on the wall. Well, now it's on video. While we're waiting, we have one announcement. Why don't you just go ahead and set up?
Hello, everyone. My name is Jorge. I run a sister group called Lansing. We're having our meetup this coming Saturday at 1 p.m. And it's going to be about writing serverless applications using the Inspire.io API. You're all more than welcome to come by.
Who's going to be doing the talk?
A representative from Inspire.io. Yeah, it's pretty cool.
Where's it going to be?
It's going to be on Pico, not that far from here, Pico and Brea. If you, yeah, close to Hauser actually. Yeah, Pico and Hauser. So if you go to our website, lampsig.org, is spelled LAMPSIG.org. We have all the details there. At 1 p.m.
Yeah, we usually have pretty good talks.
Thanks. Thanks.
So, so logged in is Limon. For those of you who don't speak French, Limon is the number one newspaper in France. It's been around for a century or so. It's got primarily a French-speaking audience, but we do see people coming from kind of around the world, French expats around the world who want to read the news. Go to lemon.fr to read the French view of what's going on. So this is logged in as Limon. Unfortunately, you can't see well on the screen, but this is this is our JavaScript tag. It's only a few lines, and basically all it does is say, go load this file. So it's fairly innocuous. What the tag does, it looks in the browser and it says, do nothing. Wait until the page load is completed. Wait 2 more seconds to make sure that everything's kind of quiet and quiescent and no one's doing anything. And then I want you to start doing stuff. I want you to start, here's a list of test objects I want you to go grab. Here's a file on EC2 Virginia. Here's an application that's running on Google App Engine. Here's a file on various Akamai maps. Go grab these things for me and send Cedexis the results. Send me the data on throughput and availability and response time. And if you get an error or timeout, send me that information as well. But their goal is that we don't need to capture every user. It's not like Google Analytics where you want to get everyone. Our goal is, if somebody clicks on a page, clicks the next one, we don't grab any data, that's fine. But as soon as you stop and start watching a video on Dailymotion, you start reading an article on MSNBC, you're not doing anything right now, you're not busy, so we'll use a little bit of bandwidth in the background. And most of the files we download are very small, so their idea is to not really be disturbing what else is going on. Some of our customers, like Dailymotion, they actually set it up so that they'll download 1 meg files in the background while you're watching a video, because they really don't want to see the throughput to their various data centers and the various CDNs that they use. But that's sort of their choice. Generally, for other customers, they're just more small files. So that's the tag, and then this is Limon. In this case, has provisioned. They've got an account on Contendo. They've got an account on Edgecast. They've got an account on Iliad, which is a local French ISP that has a domestic CDN service, and they've got their origin server. And those are really the 4 things that they kind of choose from. And then they've got a set of applications that they've deployed on Cedexis. Sort of a laundry list here of applications for various properties. So we look at it. Here's www. Here's the primary Limon.fr site. every application on Cedexis has an app ID, mostly. So you point your DNS at this app ID. We don't care how many different websites or applications. For us, it's just you provision an app ID, and you provision as many of these applications as you want. The application itself is just a PHP script that again defines the behaviors. In this case, they're selecting between Contendo and Edgecast. They're just taking performance data, round trip time data. There's an availability threshold. So as long as both those providers are above 90% availability for that location, they just pick the fastest one. I don't think in this case there's no padding. They're not biasing it based on cost or anything. They're just saying, as long as they're both up, pick the fastest one.
Are you only supporting PHP or?
We only support PHP today. Early on, when we're 25-person startup, so we surveyed the initial 16 beta customers we identified and said, Perl, Python, or PHP, pick one. And the sort of the lowest common denominator was PHP. It's for what we're doing, for the kind of things we're doing, it's good enough. We've sandboxed the hell out of it so that we run many thousands of applications on our boxes, and you can't step on the other person. If every app is when you provision an app, you have to give us an emergency, basically a backup. If your app doesn't respond within 1 millisecond, we just hand back that answer no matter what. That way, if you shoot yourself in the foot and you push up a bad app, at least we have something to hand back. We never DDoS we never DOS your site. But we're very aggressive on your app needs to be. We need the average response time for applications on our box is 40 usecs, 40 microseconds. So if it takes you a whole millisecond to hand back an answer, we just assume that you're dead, and we just hand back the
this script runs on your servers.
Yeah, so we have load balancers running in 48 data centers around the world. We run 3 Anycast networks. And so when you go to our portal, you upload, so if Lamone right now went, I don't want to screw up Lamone, but you can upload a new script. It gets pushed out to all of our load balancers automatically. And then all the DNS traffic gets processed by the user script. And we find because we're selling to IT admins, it's good enough. For people who are really not technical, we have the there's we call it a quick start tool, which allows you to create a simple app. Okay, I just want round robin, and it'll just ask you some simple questions, and you can just basically create the script for you on the back end. So some people don't want to deal with PHP. We sort of can hide the PHP behind a nice GUI, but for the most part, our users really want the flexibility and the power to be able to write their own code. There's a library of sample apps you can.
So it's not a redirect. You take over the DNS duties
for that particular domain. So they still have an authoritative name server somewhere that's handling their NX records and all their mail and everything.
Okay.
So we don't become a primary. We're not a DNS hoster like GoDaddy or UltraDNS. So they still have somebody else.
For www.
They point that at us, and then we basically we're the fork in the road. So instead of CNAMing your website to Akamai, or CNAMing it to CloudFront, you CNAME it to that app ID at Cedexis, and then when we output back out, what your app hands back out as a decision is the CNAME either do we hand back the Edgecast CNAME, or we hand back the Contendo CNAME, or the Akamai CNAME. So in case you're running your app on multiple EC2 regions, you would have www.myapp.com. It would be CNAME to some Cedexis application, which would either hand back a host name that pointed to your Amazon EC2 Ireland location, or it would hand back the host name.
So this is a redirect, really not a DNS server.
It's DNS. No, it's pure DNS. It's all happening with the DNS layer. But DNS, you can say this chain. Within DNS, you can do the chain of CNAME responses, which eventually resolve to Ireland.myapp.com, which but then that final resolution goes back essentially to you. So you're adding the latency of an additional DNS lookup. On average, globally, most places where our latency is about 7 to 10 milliseconds. There are places where we don't have good coverage where it can be as high as 50 milliseconds just for that DNS lookup, but again, it's cached in the ISP, so not every the users only see that once, maybe, if no one else from that location has asked for that same thing recently. But if I could save you a second on page load times, then it's worth it to pay the extra 25 milliseconds latency fix for DNS help. At least that's our theory.
Great.
Cool.
Thanks
Thanks,
very much. Cool. So I'm just going to nag you one more time if you can just take your chair and we're going to line it up over here. But other than that, we'll see you guys on the 19th for this Saturday at 1. And thank you very much.